Okay, it says that there are the letters which are given A, D, R, O, I, T, and 6 letter string, the words can be formed. Now, using these alphabets, how many words can be formed such that it neither have T in the beginning, right? So there are 6 alphabets which are given. So T should not be in the beginning, neither A should be at the end. Now, how many such words? First, what is the total number of the words which can be formed? Now, total words which can be formed, that is using these alphabets, 6 words, 6 alphabets are there. That means 6 factorial words can be formed, right? If 6 factorial words, that's the total number of words. Now, these 6 factorial words will have a lot of cases. We'll have a case number 1, will have the word type of word which starts with T. Okay, there will be the word 2, 4, 6. There will be a word which starts with the letter T, ends with A. Now, this case we have to subtract which starts from T. Why? Because we do not require T at the beginning, do not require A at the end. That means this particular case has to be subtracted. Now, how many words are there such that it starts from T and ends with A? Now, let's say that first position, how many choices? Only one. Last position, how many choices? Only one, right? Out of these 6 digits, T position fixed, A position fixed. So how many choices for the second position? That is 4, then 3, then 2, then 1. That means how many such words are there? Can we write this as 4 into 3 into 2 into 1 as 4 factorial words? Now there will be a case number 2. Case number 2, there will be some words which starts with T, which starts with T, but do not end with A, right? These words also have to be subtracted from the total. Now, how many such words are there which starts with T? Let's say the first position, only one alphabet, right? Out of A, D, R, O, I, T, T, it starts with T, but do not end with A, right? So how many choices for this particular position? T already fixed, A cannot come in this last position. That means 4 choices for this position to be filled. Then how many? Out of six alphabets, one fixed here, T fixed, one used here. That means how many choices for the second position? Out of 6, 2 choices cannot come, right? 2 alphabets cannot come. Why? Because you have fixed T here, you have used out of them one of the alphabet which is not A here. So that means out of 6 you have used 2. That means there are 4 choices for this particular position. Then 3 remaining, and then 2, and then 1. That means this particular case can be written as 4 into 3 into 2 into 1 is 4 factorial. Can we write 4 times 4 factorial? This case, 4 times 4 factorial. Now, case number 3. Can there be a case number 3? There will be a case number 3 wherein can we say that case number 3 wherein it ends with A. There will be some words in this 6 factorial which ends with A but do not start with T. Now, how many such words are there which ends in A? Let's fix the position of A. That is a last position. How many choices? Only one. We have fixed A. How many for the leftmost position? This position. A cannot come, T cannot come. Out of 6, 4 choices for this. Now, for the second position, you have used one alphabet here, one alphabet here. That means out of 6, 4 digits or the 4 alphabets you have used, how many are remaining? That is 4. Similarly, you have used 3 alphabets out of 6. So 3 remaining, 3 choices, then 2 choice, then 1 choice. So how many such cases are there, or how many such words are there in which it ends with A but do not start with T? That is 4 into 4 into 3 into 2 into 1. So 4 into 3 into 2 into 1, can we write it as 4 factorial? So it will be 4 times 4 factorial. Got this? Now, these are the 3 cases which have to be subtracted from the total. Let's solve and subtract from the total, right? To find out how many cases do not start with T, do not end with A. Now, that means required number of words, that is 6 factorial, minus case number 1, that is 4 factorial, minus second case, that is 4 times 4 factorial, 4 times 4 factorial, minus the last case, that is 4 times 4 factorial, 4 times 4 factorial. Now, simplifying 6 factorial, can we write it as 6 into 5 into 4 factorial, minus 4 factorial as it is, minus 4 times 4 factorial, minus last term, that is 4 times 4 factorial. Now, 4 factorial can be taken common throughout. If we take 4 factorial everywhere common, what is left then? What will be left? From the first bracket, 6 into 5, that is 30, minus 4 factorial taken common, 1 remaining, minus 4 factorial taken common, 4 remaining, minus from the last term, 4 factorial taken common, 4 remaining. That means inside the bracket, this is remaining. 4 factorial, that is 24. 30 minus 1, 29. 29 minus 8, 21. So our answer has to be 24 times 21, that is 504. Now, if you know this product, that's good. Otherwise, just multiply the unit digit. 1 into 4, 1 into 4, that has to be the answer. The unit digit has to be 4. From the options, only one unit digit is 4. That is option D. That is the correct one here, right? So that is what this question was all about, right? I hope you understood the question. If you understood the question, do like, so that I'll be making more videos based on the questions which are there, right? Thank you for watching. I'll be sharing this link of the video on the GMAT Club forum. Discover our courses which are there on the Udemy, which will help you with your quant syllabus. And I'll be using this link of my Udemy video in the description, so you can review that as well. Also do like and share the video. That would be great. Thank you again for watching.